The last part of geologic geometry then is skew boreholes. Now, with skew boreholes, what you really have with them is what I've been explaining all the time when it comes to profiles and those kind of things, and that is where people go onto the top of a hill and they drill a hole in a number of places to be able to figure out where the head wall of your stratum is and where your footwall of your stratum is. Okay. Now, with this, the skew boreholes is simplified to only having two holes. Okay. And the reason that they're called skew boreholes is skew just means that they're anything but vertical. Okay, so you have vertical boreholes which are just straight down, and then you have skew boreholes which are at any other angle. Okay, to vertical. So vertical boreholes and skew ones. And what you have with it is that you have your borehole here, so you have A drilling down through the earth and you have B drilling down through the earth. Okay. And what happens, as I said to you before, is that it drills down and drills down and drills down, and all that comes up is mud until it gets to the point when you get to your stratum. Once it gets to the stratum, then the drill bit starts bringing up whatever it is that you're looking for. So let's say if this is gold in this case, gold would start coming out of the top. And the people on the top then will say, right, we're hitting gold at a particular depth. So you'd be hitting it at whatever that distance is, okay? And then they keep drilling down and keep drilling down until they stop seeing gold and they start seeing mud again, okay? And that's when they get to the footwall. So that distance would be the distance from here to here, okay? And then once they know those two distances, so that once they know the distance that it took to get to the head wall, and they take that away from the distance it took to get to the footwall, then they have what would be the thickness of the stratum then in between the two. So the thickness of the stratum would be in there. So whatever that distance is, okay? That's your thickness. And what we're really looking for with the skew boreholes is we are looking for mostly that thickness of the stratum. Okay, so we'll be looking for the strike, we'll be looking for the dip, um, like we've been looking for before, but also now we're going to be looking for the thickness as well. Okay, now what this topic basically is that it is skew lines. Okay, so where we had in um, the last stuff that we were looking at, we were looking at it and they were basically laminar planes, okay, for when we were looking at the head wall of things. Um, Skew boreholes are basically the same as skew lines, okay, once we've set up the beginning. So the beginning of it is different, but once we found, looking at all this information, once we found the line here, so AHBH, which is the line for the head wall, and AFBF, then it becomes a skew lines question. Just as well, so what the AH and the BH is, so you have A head and a foot, so that's on one of your holes. Then you have your second hole here, okay, coming from B where they drill down, and you get the BH, so the B head wall and the B foot wall. And then what you can do is you can join those to each other, and you'll have a line that's on the stratum, okay, and the same down here. So you have a line here that's on the head wall, and you have a line down here that's on the foot wall, but you'll see that a little bit more detail when we go through it in the questions. Okay, so what we have is we have the setup, which is basically to find. It's all about finding AH and BH and AF and BF, and once you have those, then it becomes very similar to a skew lines question, if not exactly the same as a skew lines question once you found those. Okay, so you'll see here that this is the question, and there's a lot of words in it. Okay, so you have to break it down quite effectively to make the question manageable. So it's split up into really kind of four different bits. But what we have first of all is we have on the contour map A and B are points whose altitudes are at 80 meters and 100 meters respectively. So that would be our first piece of information. Okay, and then on the map B is located 80 meters east of A, and that would be 2. Okay, now what those points 1 and 2 are for, okay, is to find where A and B is. So we have the blue ones are to find where the point A is and where the point B is. Okay, nothing to do with the boreholes yet, just finding A and B. Second piece of information then you have a skew borehole. A is drilled in a southerly direction and plan and has an actual inclination of 45 degrees to the horizontal plane. So that would be my third piece of information. Okay, it reveals the top and the bottom surfaces of the stratum at altitudes of 65 and 25 meters respectively. So that would be number 4. So that's my 4 piece of information. And what they're giving you okay, is that it is giving you this line, okay, and it is giving you the point for AH and AF, okay. So that's what those are giving you. And actually, to get even to be even more detailed about it, if we take this out for a second, so what I can even go into a bit more detail. So what we have is, if we take it here, that number 4, sorry, number 4 here, so it reveals the top and the bottom surface. Number 4 there is giving us this and this, okay. So we have 1 and 2 are giving us where the holes are drilled from. Number 3 then is telling us the angle of the borehole, so where the borehole is going. And then number 4 is giving us the AH and the AF, okay. The next bit then is we have a skew borehole from B is drilled in a northwesterly direction and plan and has an actual inclination of 65 degrees to the horizontal plane, okay. That is our 5th piece of information. So in there, that is giving us the borehole here, okay. So we have the 5th piece giving us the angle that this is being cut down at. And then the final piece of information is giving us, so it reveals the top and the bottom surfaces at a stratum and altitudes of 80 meters and 45 meters. So the 6th piece, so the last piece of information, so number 6, tells us where the BH is and the BF is, okay. And then it's looking for what the question is then, so it's to find the strike, the dip, and the thickness of the stratum. So what you'll see is it's really split up into the 6 pieces of information, but it's kind of split into kind of 3 main parts. There is finding your AB, then all of the information that you need for your skew borehole A, so the point 3 and point 4, and then the third thing then is giving you all the information for your other boreholes, so that would be point 5 and point 6. That would help you to find those, okay. And once you've done all of that information, once you've found it all, that will give you then your AH and your AHBH and your AFBF, and they're the lines we're going to use to solve the last bit down here at the bottom, okay. So we don't solve any of this until we have all of this set up. So now we'll have a look, we'll go onto the board and start looking at how we'll put these into action. Okay, so to start off then, when we look at our sheet, the first thing we're going to do is we're going to have a look here on at the information we're given. And we're given that A and B are 2 points whose altitude are 80 meters and 100 meters respectively. So I've gone to my sheet and I have put in an XY line, and I've just put in a line at 80 and a line at 100, okay, because I know that I'm going to need those bits of information. The next thing then is we have on the map, B is located 80 meters east of A. So it's important to remember from when we're looking at the geologic geometry part, so with the road geometry bit, that if we're looking at north, south, east, and west, we're always looking at the plan. Okay, so if it gives you a direction using the compass coordinates, then we're always using the plan. So what we're going to do is we're going to put B in kind of a random place that we know is going to be roughly where we need it to be, and then we're going to have 80 meters east for A. So if it's east, it's going to be going from right to left. Okay, so we're going to put in B, and then we're going to go 80 meters east. So what I'll do is I'll pick a point here to start off with. So let's call this B. Okay, and then I'm going 80 meters east. So east is in this direction across. I'm going to go 80 meters, or 80 millimeters in this case, because they're equal to each other here, and I'm going to put in A and put in B. And once I have it then in the plan, I can bring it up and I can find point A and point B in the elevation. And we were told that A is at 80 and B is at 100. So I have A and B. Okay, so that's our start. Okay, after that then what we have is, get the wires out of the way. After that what we have then is our next piece of information. So we look and we see that a skew borehole at A is drilled in a southerly direction and plan and has an actual inclination of 45 degrees at a horizontal plane. So what we have with that is, if we have a look at the sheet here, I have that it is going to be coming straight down, so it's going to be in a southerly direction of the plan, which means going straight down here. Okay. But I don't know how far down it's coming. Okay. And part of the problem we have is that because it's coming straight down in the plan, in the elevation, we can actually draw the borehole here straight away in the elevation, is coming straight down like that. Okay. But from that information, from what I have here, I can't actually see how long this is to be able to put it in. So I have to be able to see how long this actually is. Okay. So what we do is we do a bit of rotation of this point to be able to find where it's actually going to go. So if I go to this and I'm told that A is drilled at 45 degrees, then what I have is 45 degrees is going to be coming from A up here. So I draw my line down here. Now, ideally, I would have started this a little bit further over. Okay, so just bear that in mind when you're doing yours. So I'll just lengthen my XY line here for that. Okay, and what I've done here is that I've drawn a line at 45 degrees. Okay, so I have a line of 45 degrees drawn here, and basically what I'm going to do with that is that that's now giving me the length of my borehole that I'm looking for. So what I have to do is I have to bring it from being beside it here, very similar to how we would have done it when we were doing anything in solids in contact. Okay, it's a very similar idea where we're taking it, I'm drawing it over to the side first, then I'm going to bring it down, and then I'm going to bring it around. Okay, just like we would have taken the center of a sphere if we were bringing it around, or cone or something like that in solids in contact. So what's going on with this, might be no harm in putting it in, is very similar to solids in contact. Okay, and again, the whole point of the section C questions in this, so the applied geometry, is taking stuff that we know and using it for kind of purposes that are a little bit more concrete. So what I would do with that is I would bring it down, and then as we would have done, we would have had a center in solids in contact. I'll measure that across, and that then gives me the length of my borehole at A. Okay, now the second piece of information then, so for B then, so that gives me where borehole A is. For B, it says, now I'm going to skip over the top and the bottom surfaces just for the moment. The skew borehole at B is drilled in a northwesterly direction in plan and has an actual inclination of 65 degrees to the horizontal plane. So northwesterly and 65 degrees. So we're going to go with northwesterly direction, and then what we're going to have is we're going to go up into the elevation. I'm going to draw it over to the side because again, I don't know how long this is going to be. Okay, so what I'm going to do is I need 65 degrees. The easiest way to get 65 degrees will be to do it with your adjustable set square. Set your adjustable set square to 65 degrees. I don't have my adjustable set square here with me, so I'm just going to pick a point here. I'm going to go 65 degrees, just to give me a line here to go parallel to, and then I'm just going to slide my set squares to find my 65 degrees. So what I have is B here over to the side. Now this is to the side, it's not the actual one, okay, for now. And what I'm going to do then is I'm going to do exactly the same as what I did for this one. So I now have a 65 degree line down here. So this is 65 degrees. I'm going to use B as my center here. I'm going to project down. And I am going to rotate B around until it hits my line, and then that gives me where the skew borehole at B stops. I can then bring it up into my elevation, which allows me to draw in my borehole. But when I go back to my sheet, there's going to be a lot more lines on it than there should be at this stage, but unfortunately my computer didn't record a small portion of the question, so I just have to re-record it again. But I'll go through with what I have here anyway. So what we have for the next bit is that we have our borehole A is put in there in the elevation in the plan, and then we have where it reveals the top and the bottom surface of the stratum at altitudes of 65 and 25 respectively. So what we're going to do is look here, and I've come up 65 up to my AH and up 25 up to my AF. And the problem I have with this is that to bring it down into the plan, when I project it straight down, I can't actually find where these two are on that line because of the fact that it's a southerly line here and going, so it means it's vertical. So what I have to do is I have to bring it over to my line here where I got my 45 degrees first. So I have it over here and then over here. So you could say AH over here and AF. And then project it down to my view down here, just like we would have done when we were looking at solids in contact. And then rotated it around the plan to find where AH and AF actually end up being. Okay, so rotate it around to find them in there. Then once we have that one, then it is a matter of looking at the borehole B and looking at where it says that its head wall and foot wall is. So it has, in this one it says that it reveals, so for B reveals the top and the bottom surface of the stratum at altitudes of 80 and 45. So with this one then, with 80 and 45, what we're looking at is I've come up 80 millimeters, drawn a line across, come up 45 millimeters, drawn a line across, and then because this one is at an angle, once I have the BH and the BF here, I can just come straight down and find it on this line here. Okay. Then once you have those, what you have is that your head walls join up. So AH joins to BH. Okay, so I have the blue line here, and I get the foot walls as well. So I have AF and BF join up as well. And then the same thing happens down here in the plan. So I get AH to BH and I get AF to BF. Now, once you have your head walls and your foot walls, basically then this just becomes a skew lines question. Okay, it's all the construction we're using is going to be the same as in skew lines. And what that also means is that once you have the head wall and the foot wall and the two views, the borehole A and the borehole B, so these lines they don't serve any purpose anymore. So they were really just to find my head wall and my foot wall and my head wall and my foot wall down here. Okay, so the next bit then is to go and have a look at how we find the strike, the dip, and the thickness. And this will bring you back to when I recorded it the first time. So it'll go back to being slightly less on the sheet again. Okay, now in order to explain this kind of effectively, I've come back here to the skew lines chapter, so to page 168, and looking back at what we did when we were looking at skew lines. Okay, now the two things you'll see with this is that, and you'll remember this, is that with skew lines, what we look for is we look for two different things. So we look for the shortest horizontal distance and we look for the shortest distance. Okay, so we have those two things, but the two of those things start off with the same construction. Okay, so when we're doing these, when we were looking for, so in this example, it's the shortest horizontal distance, we found what's called a strike like we had before. We didn't call it a strike at the time, but we had our level line here, okay, coming across. And then what we did was level here, and then we went parallel to the other one from that. So we went from here parallel to this one, okay. That gave us a point out here, which allowed us to find the strike basically. So what you have is you have your O out here, and then finding my O out here, okay? And then what all that did was it gave us a line that when I joined that back to A, okay, it gave me a line to figure out what angle I needed to take this auxiliary at, okay? From there then, looking at this, we got the two skew lines as parallel lines. Okay, now those two parallel lines are actually all that we're looking for in the mining geometry that we're going to look at now. Okay, so we're going to look for the two the head wall and the foot wall, we're going to look for them to be parallel, and that's going to give us the information that we need. Okay, so what we have with that, if I go back to what we're looking for, so that's on 368. Okay, so what we have then is that we're looking for the strike, the dip, and the thickness of the stratum, and we'll get those three pieces of information from just going to that first step that we would have used in skew lines. So on our sheet then, what we will do is take what we know about skew lines, and I am going to go Doesn't really matter which ones you do from, but I'm going to go from AH and I'm going to go horizontally. Okay, and so I'm going to come from AH, I'm going to come horizontally across here. Okay, so that's my level line, and then from the other end of that line I'm going to go parallel to my AF and my BF. So what I have then is I get my line coming along here. Okay, and I'm going to bring that down into my plan. So that gives me the point O. Come down into my plan then, and what I am going to do then is from BH I'm going to go parallel to a FBF again. So I'm going to go AFBH, sorry, AFBF. I am going to go parallel to that from BH. Okay, and then that gives me my point 0, and then point 0 goes from AH, which means that I get a line coming down here like this. Okay, and this line here is my strike. Okay, so my strike comes down here. Okay, in this one there's no need to give it any labeling to north. Okay, this is just, you can just put in your label as strike. You only need to label your strike to north when you're doing the road geometry one. If you were to label this and put in north into it, you wouldn't lose any marks for that. Okay, so it's up to you, but you don't need to put it in here. So then what I have, once I have my strike then, what I'm going to do is I am going to take an x1, y1 line perpendicular to that to make sure you do that accurately. And I'm going to measure now. I'm going to go quite close to this just to make sure I have enough room. I know the strike is going to end up in this view, but that's not that big a deal. So x1, y1, okay. And all I'm going to bring is I'm just going to bring the head walls and the foot walls down. So I'm going to go parallel to that. I am going to bring down just the 4 points. I don't need any more than the 4. So I get my B's and I get my A's. So the first one's already brought down. Okay, then I'll take my distances from my elevations. So I'll get AF, label it as I go. So AF, and I'll go and get BF. So BF, just check that I have the right size here. More BF. And then I'm going to get my AH. So AH and BH. And then if everything is worked out with that construction, then these should be parallel to each other. So BH. And then I'll put in my 2 lines here. So I get my first one here from my head walls, and then I get my foot walls. Okay, so we now have the one where they're parallel to each other, which is exactly what we're looking for. Then what we're looking for then is that they want us to find the dip and they want us to find the thickness. So first of all, the dip we know is going to be the angle to horizontal, the way that it was before. So just to be able to measure that properly, I am going to just draw horizontal lines. So rather than, because I won't be able to actually end up bringing it to the top. So if I go parallel to that, and I can put in my line here, okay, and then I'll be able to put in my dip. So just for labeling purposes here, I'm putting in this red bit. So my dip is the angle from there to there, so that's my dip. And I'll measure my angle. So I have here my dip is 11 degrees. Okay, and then my thickness, and this is the important thing, the last thing you need is that your thickness is the perpendicular thickness. Okay, so your thickness is, and we've seen this before in the other ones that we've done, but my thickness is going to be perpendicular to the two horizontal ones. So I have my dip and then my thickness. It's important to put in this line to put in your labeling. That's my thickness. And in this case, my thickness is 35 millimeters. And that is then my question completed. Okay, so just a quick recap of that then. When we're looking at this, this is really a combination of, so number one is the combination of solids in contact in the setup, and of skew lines then in the rest of it. Okay, so in terms of finding the other piece of information, so your dip and your thickness. So that's really, when you're looking at this question, you're looking at your revision of where everything is coming from. They're the two topics that are really applied in this.